In the vast tapestry of our solar system, few destinations capture the imagination quite like Venus and Europa. These worlds, so different from Earth and each other, hold secrets that could profoundly change our understanding of life, planetary processes, and the very nature of the cosmos. As technology and scientific curiosity propel us forward, recent breakthroughs and ambitious missions are bringing us closer than ever to unlocking these celestial mysteries, while at the same time, cosmologists are refining our view of the universe's grand shape and destiny. Venus, often called the morning star or evening star, has long stood as a beacon in our night sky. For centuries, it was shrouded in mystery, its thick, toxic atmosphere and runaway greenhouse effect rendering its surface nearly invisible to our instruments. Yet, recent years have seen a renaissance of interest in Venusian exploration, driven by the tantalizing possibility that life might exist in its cloud tops. In January 2025, a new chapter unfolds with the launch of the Venus Life Finder mission, a collaboration between Rocket Lab and the Massachusetts Institute of Technology. This innovative mission aims to answer one of the most profound questions. Could life exist on Venus? The Venus Life Finder mission will deploy a small probe into the planet's atmosphere, equipped with an autofluorescence nephelometer, a device designed to analyze the composition of cloud particles as it descends through the thick Venusian clouds. The probe's journey will be brief but intense, passing through layers of sulfuric acid and temperatures hot enough to melt lead. Its goal is simple, yet audacious: to detect organic molecules that might hint at biological processes in the upper clouds, where conditions are less hostile than on the surface. If successful, this experiment could spark a revolution in our understanding of where life can thrive, challenging the notion that Earth-like conditions are required for biology to flourish. But Venus is not the only world drawing attention. In August 2025, the European Space Agency's Jupiter Icy Moons Explorer, or JUICE, executed a critical flyby of Venus, passing within just over 5,000 kilometers of its surface. Although the spacecraft's instruments remained silent during this maneuver, thermal constraints demanded caution. The gravity assist from Venus was essential, increasing JUICE's velocity by 5.1 kilometers per second and setting it on course for its next Earth flyby and ultimately its main destination, Jupiter's moon Europa. Europa, with its gleaming icy surface streaked by reddish lines, has long been a focus for scientists hunting for extraterrestrial life. Beneath its frozen crust, evidence points to a vast, salty ocean kept liquid by tidal heating from Jupiter's immense gravitational pull. The prospect of drilling through Europa's ice to reach this hidden ocean is one of the most thrilling endeavors in planetary science. While no recent missions have yet pierced the ice, preparations and planning continue in earnest. NASA's upcoming Europa Clipper mission, for example, aims to conduct multiple flybys, mapping the surface in detail and using sophisticated radar to probe the thickness and composition of the ice. The ultimate goal: to identify promising sites where future missions might one day land, drill, and sample the subsurface ocean. The scientific community is particularly captivated by Europa's potential habitability. Conditions beneath the ice may be similar to Earth's deep ocean hydrothermal vents, where life thrives in darkness, fueled not by sunlight, but by chemical energy. If Europa's ocean harbors life, it would be one of the most significant discoveries in human history, a second Genesis, independent of Earth's, demonstrating that life can emerge wherever the right conditions come together. As explorations of Venus and Europa progress, scientists are also turning their gaze outward, contemplating the ultimate context in which these worlds exist, the shape and fate of the universe itself. Recent advancements in cosmology have allowed for more precise measurements of the universe's expansion rate, known as the Hubble constant. These refined measurements are more than just numbers. They help determine the age of the universe, the dynamics of cosmic expansion, and whether the universe will expand forever, slow to a stop, or reverse into a contraction. The debate over the Hubble constant has sharpened in recent years, with different methods yielding slightly different values. This Hubble tension has sparked a wave of new research, as scientists seek to reconcile these differences and understand what they might imply about the universe's fundamental properties. The expansion rate informs models of the universe's overall shape, whether it is flat, open, or closed. Current evidence points to a universe that is remarkably flat, stretching out in all directions with no discernible curvature. This flatness, combined with the accelerating expansion driven by dark energy, suggests a cosmos that will continue to grow colder and emptier over billions of years. A big freeze scenario. Yet the implications of these findings go beyond the fate of distant galaxies. They inform our understanding of the forces that govern everything from the formation of planets and stars to the conditions that allow life to arise. As we seek organic molecules in Venus's clouds or contemplate drilling through Europa's ice, we are also probing the limits of what we know about matter, energy, and time itself. These interconnected quests, searching for life on Venus, exploring Europa's hidden ocean, and measuring the universe's expansion, are more than isolated scientific endeavors. They are manifestations of humanity's deepest curiosity, our drive to understand our place in the cosmos. Each mission, each experiment, stands on the shoulders of decades of discovery and points the way to future breakthroughs. Yet, as promising as these missions are, they face challenges. Venus, for example, risks losing momentum in scientific exploration due to shifting priorities and funding constraints. Many researchers warn that without continued investment, the bright future of Venus science could dim, delaying answers to questions that have fascinated generations. A robust program of planetary exploration is crucial, not only for the pursuit of knowledge, but also for inspiring new generations of scientists, engineers, and dreamers. In the coming years, as probes dive into Venus's clouds and spacecraft map Europa's icy surface, we will edge closer to answers that have eluded us for centuries. Will we find evidence of life beyond Earth? Will we uncover secrets about planetary formation, habitability, and the origins of water? And as cosmologists refine their measurements, will we finally grasp the true shape and fate of our universe? These journeys, both literal and intellectual, remind us that exploration is not merely about visiting distant worlds, but about expanding the horizons of what is possible. With each new mission, each new discovery, we take another step toward understanding the grand story in which we all play a part, the story of the cosmos and our place within it.